Hey everybody, welcome back. Thanks for watching. So we want to establish a couple neat results from trigonometry. First, we want to show that the arctan of 1 plus the arctan of 2 plus the arctan of 3, well, that equals pi. And second, we want to show that the arctan of a third plus the arctan of a half is pi over 4. I want to remind you, don't forget to like the video, subscribe to the channel, and share. Lots of cool math stuff on the horizon, so you want to stay tuned for sure. Okay, so let's establish these cool results. Okay, so here I have a few triangles, and I just want to label the sides and the angles. And so here is a right angle, here is a right angle, and here is a right angle. So this side has length 1, 2, so length 2. This side has length 1. This side also has length 1. Let's see here. So this side over here, this would have length 3, right? 1, 2, 3. And so now we can use the Pythagorean theorem to find the hypotenuses. And so this length would be, looks like the square root of 5. This length would be the square root of 10, again by Pythagorean theorem. And then again by Pythagorean theorem, that must be the square root of 5. Okay, so I've got an isosceles right triangle, so that means that these two angles must be pi over 4. But another way to say pi over 4 is the arctangent of 1. So yeah, arctangent of 1 is pi over 4. Now to find this angle right here, we can just compare these sides, and if I take the tangent of the angle, I get 2 over 1 or 2, so tangent of the angle is 2, so the angle must be the inverse tangent or the arctangent of 2. So that's arctan of 2. Okay, so what about over here? So this angle, well, the tangent of the angle is 3 over 1 or 3, so the angle itself is the inverse tangent or arctangent of 3. So I can use that sort of thinking to label this angle and this angle. So let's go ahead and do this. So for this angle here, this would be the arctan of 1 over 2 or a half. So let's label it like this. So arctan of a half. And then here for this angle, this is going to be the arctangent of a third. Okay, so once we label everything, we have a free result. I mean, these are supplementary angles, so we know that their sum is equal to pi. So that's really, really nice. Really nice. And so much more satisfying than reaching for a calculator and saying, maybe it's true. I mean, we're dealing with irrational numbers, right? So this is nice, concrete geometry. So for sure it's true. So satisfying. So arctan of 1 plus the arctan of 2 plus the arctan of 3 is equal to pi. How cool is that? Okay, so let's actually use this result to prove, what else do we want to prove? We wanted to prove that the arctan of a half plus the arctan of a third is pi over 4. In order to do that, let's maybe recall something. So, what did we say before? We proved the following. So if x is a or strictly positive real number, we'll say it that way, then we had the following. So the arctan of x plus the arctan of 1 over x is pi over 2. Okay, so let's call this 2. So let's use 1 and 2 together to prove that the arctan of a half plus the arctan of a third is equal to pi over 4. Okay, so goal, we want to show that the arctan of a half plus the arctan of a third is pi over 4. And we're going to do that using 1 and 2. After we do that, maybe you should pause the video and see if you can find a purely geometric argument for that. Okay, so let's make some observations. So I know that the arctangent of 2 plus the arctangent of 1/2 by number 2, we know that's equal to pi over 2. And so similarly, the arctan of, well, 3 plus the arctan of 1/3 is also equal to pi over 3. And I also know this addition postulate from geometry, so let's recall. If A equals B and C equals D, then A plus C equals B plus D. So I've got exactly that here, so let's take the sum of the left, and that'll be equal to the sum of the right. By the way, this should say pi over 2. You probably caught that as I was talking, I'm sure you did. That's pi over 2. Okay, that's real life though, right? That happens. But we caught it. So that's just fine. So let's go ahead and take the sum of the left side. So that's going to be the arctan of 2 plus the arctangent of 3 plus the arctan of 1/2 plus the arctan of 1/3. And that's going to be equal to pi, right? Pi over 2 plus pi over 2 equals pi. Okay, so what can we do now? Let's add the arctan of 1 to both sides. I mean, this is not the only way I could do this, but I think by showing all the steps, it makes the process very, very clear, and that's my goal. So I'm adding the arctan of 1 to both sides, but what is the arctan of 1? The arctan of 1 is pi over 4. So instead of writing arctan of 1 on the right, which I could, I'm going to write pi over 4. They're the same thing, right? They're equal. That is the arctan of 1. Okay, but notice something, right? Let's see here. So this quantity right here, what did we just prove? We proved this was equal to pi. So we've got pi plus the arctan of 1/2 plus the arctan of 1/3 equals, well, I could call that 5 pi over 4, but I could also just leave it because I'm about to subtract. And if I subtract pi from both sides, we get our result. How cool is that? So I think it'd be really cool if you could pause the video, maybe work with the triangles and see if you could give a purely geometric argument for that. So can you establish that same result geometrically?